This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
My wife and I were watching a TV series called Outlander, which includes a woman who travels back in time. So my wife asked me, is time travel possible? And I said, well, we don't really know. This flow of time is very mysterious. Why does time progress? That has bothered people from Aristotle to Augustine to Einstein. My theory postulates that space and time are so tightly linked in general relativity that if you create more space, you're creating more time. If the expansion of the universe, starting with the Big Bang and now coasting ahead, is constantly creating more space, it must also be creating new time. And the newly created space is the space between the galaxies, and the newly created time is what we call now. Now, new time has just been created. If this theory is right, then we need a possible real test where we are creating new space. Just as I was finishing the book, along came LIGO. What they saw were two black holes, 30 times the mass of the sun, coming together in a collapsing event and making one huge big black hole. This creates gravity waves, so we see the gravity waves coming. When this happens, you are locally creating millions of square miles of new space. I said, if you're creating new space, you're creating new time. And I calculated how much it was. It turns out to be about 1,000th of a second. But we should see this pulse, and then as they come together, it becomes what they call a chirp, and then it's gone, because now it's just one object. It's not emitting gravity waves anymore. But if we look at the timing, and then the chirp should be delayed by about 1,000th of a second, because new time is being created when these two black holes get together. I think within the next few years, we're going to get such an event. When there's one that's closer, the signal will be stronger. When the signal is stronger, you'll be able to measure it to 1/10 of a millisecond, and then we should see that added delay. And if we don't see it, the theory is wrong. And if we do see it, that's in support of the theory. As a scientist, I'm not satisfied with coming up with a clever explanation. We need to test it. The thing that'll really gratify me is if the LIGO event shows that the time, the prediction that we make turns out to be true. Then I'll go, wow. I'm looking forward to getting a phone call from them saying either, gee, Rich, your theory is wrong, sorry, or congratulations, you've just explained the flow of time. My wife asked me, is time travel possible? Suppose we could destroy space, get rid of it. Then time would go backwards, wouldn't it? The only way we have of destroying space very rapidly is in a phenomenon called black hole evaporation. From this new approach of understanding what time is, the bad news is no going back in time.